Hello students, in today's lesson we are going to talk about rational number operations. And our essential question and task is to be able to choose appropriate operations to solve problems that use rational numbers. In future units we are going to be talking about using the operations. Today we're just going to talk about choosing which ones we would need. So what are operations in mathematics? Think back about the operations that you have studied so far. There are four major arithmetic processes that are used to describe changes in an amount. What are the four major operations? Add, subtract, multiply, and divide. What are some other operations? Exponents are operations. Absolute value is an operation. Square roots are an operation. So there are other types, but we're going to focus today on the four major types. So we are going to be reading a lot of real-world situations, and then we are going to be deciding what operation can represent it. We are going to have a specific strategy that we are going to use. We are going to look for keywords that will help us visualize the relationships in the problem. So what keywords are we going to be looking for that will help us visualize? Sometimes the keywords that we're looking for aren't explicitly said. Sometimes the keywords are something that we think, the words that we think in our head. So here are some keywords that we're going to be trying to come up with in our head. We have our four operations: add, subtract, multiply, and divide. And for each problem, we're going to be thinking about whether we are joining groups of different sizes. So you have $10, I have $5. When we put them together, we have $15. That's adding, joining different groups. Or are we taking away or comparing groups? I had $20 in my account in the lunch line, but then I bought lunch for $2. Now I have $18. I took away. That's subtraction. Or we could compare. You have 5 animals at your house. I have 2 animals at my house. There is a difference of 3. Comparing the two groups. For multiplication, are we joining equal sized groups? I have 5 boxes of pencils. Each box has 12 pencils in it. So I have 60 altogether. 5 times 12 makes 60. I joined 5 equal size groups. Or am I continually adding the same amount? Every day my mom gives me $2 for lunch. At the end of the week I would have 10. 2 times 5 is 10. She continually added the same amount. Last, divide. Are we finding out how much for each, or how many are in each group? So for how much for each? I have 20 pieces of candy. There are 5 kids. How much should each kid get? That's an example of division. How many are in each group? We have 18 kids in our class. How could we split them into 6 groups? That's division. Finding out how many would be in each group. We are going to use these ideas to look at some real-world problems. So as we do, we are going to practice. We are going to try to figure out which operation we would need, be able to justify our choice with keywords, and also write an expression to represent the situation. So here is our first expression. Jonathan placed an order for half a sack of brown lentils and 3 3/5 sack of green lentils. How much more green lentils did Jonathan order than brown lentils? Now it says how much more of green. How much more green is comparing the two groups? Look back at what you wrote down. What operation says that we're going to be comparing two groups? Subtraction. This problem is a subtraction problem. So what key words told us that it's going to be subtraction? It was how much more. How much more told us that we were going to be comparing. And when we are comparing, we know that that means subtraction. So we know we're going to have subtraction. Well, what two amounts are we going to be subtracting? When we subtract, we know we got to put the larger amount first. So it says how much more green. More green indicates that that's the most. So we'd have 3 3/5 take away 1/2. This is the expression that would represent this situation. At the hardware store, half of the nails are size 2D, and a sixth of the nails are size 4D. What fraction of the nails are either size 2D or 3D? Well, let's look for some keywords. The keyword that tells me and helps me visualize is either. When I hear the word either, it tells me that I don't care which one. I want to know in all. I want to combine them. What operation means to combine? There are two: addition and multiplication. Combining two different sized amounts is addition. Combining the same size would be multiplication. Are our amounts of nails the same or different? They're the same. So we're combining the same, they're different. So we're combining different sizes. And when we combine different sizes, that is addition. So we want to add 1/2 and 1/6, and that would tell us how much of the nails are either size 2D or 4D. How much they are in all. A well made of 5 identical, that means they're all the same, concrete blocks, weighed 16 kilograms. So this tells me in all, it's 16 kilograms. How much did each block weigh? If I want to know how much each weighed, I would have to split the total 5 ways. I would have to split it 5 equal ways. So look back. What operation means that we're splitting evenly or finding how much for each? How much for each? Well, that's division. So we're going to take the 16 and divide it 5 ways. How else can you write division besides with this symbol? You could use a fraction bar. 16 divided by 5. Frank made 3/4 of a pound of trail mix. If he separates 1/8 of a pound into each bag, how many bags can Frank fill? So he's going to be separating, which is a synonym for splitting, into each bag, and he's going to split into even amounts. So we're going to split evenly. Which operation means to split evenly? Division. So in other words, Frank is going to take his 3/4 pound and he's going to divide it into 1/8 of a pound bags. And he wants to know how many he will be able to fill. He wants to know how many groups he can make. How many groups of 1/8 can he make? Division. means every one of them. Each piece of cardboard is 1/10 of a centimeter thick. Now, right there tells me that each of them means that they're all the same. If Kendall stacks 7 pieces of cardboard on top of each other, so you can imagine that 1, 2, 3, 4, 5, 6, 7. How thick, sorry, that's a typo, how thick will the stack be? Well, if each one's the same, then we are adding or joining equal size groups. If we join equal size groups, what operation is that? Multiplication. So we have 0.1 centimeter 7 times. This is a multiplication situation. Jared is baking blueberry pies to sell at his bakery. He starts with 4 cartons of blueberries. So this is how much he had in all at the beginning. See how I make notes on the text? He uses, okay, that means he's going to take away. He uses 7/8 of the blueberries for the first batch of pies. He's taking away 7/8 of the blueberries. How many does he have left? Well, if he takes away 7/8, all of what he had, how many would he have left? You might be able to visualize it. If you take 7/8 away, how many do you have left? 1/8. Okay, so if we take away, that means to subtract. What number would need to go here? How much minus 7/8 would equal 1/8? 1. The word all implies everything, which is the number 1. 1 minus 7/8 makes 1/8. That one's a little tricky. Danielle watched a ladybug in the yard. It crawled 1/3 of an inch. So I can imagine that. Here it is. And it crawled 1/3 of an inch. Then rested for a bit and then crawled 1/2 an inch more. Okay, so it crawled again. How much less did the ladybug crawl on its first movement? Okay, so this one's smaller. Than on its first movement. So this one must be more. If I want to know how much less, I'm comparing these two amounts. How much less is telling me I'm comparing them? What operation compares? Subtraction. So I'm taking 1/2 and I'm going to take away 1/3. That will tell me how much further she went the second time. While scuba diving, Leela was at a depth of -6 feet. Okay, so she was down 6 feet. She was at -6. She descended, which means to go further down. So she subtracted 10 more. Descended told me to subtract. -6 minus 10. So let's summarize. Real-world situations are represented by numbers and operations. When we need to decide what operation to use, we need to find keywords that help us visualize the problem. Remember what each operation truly means. When we add, we're joining groups of different sizes. When we subtract, we're taking away or comparing the sizes. When we multiply, we're joining equal size groups or continually adding the same amount. And when we divide, we're finding out how much for each or how many per group. When you can visualize these operations occurring, it is then that you will be able to decide which represents the situation.